Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello students, in the previous sections we have studied what is normal shock. So let us study what is basic equation of normal shock, and during the shock we know the fluid goes from a supersonic flow to a subsonic flow, during which how these two are related to each other, that is the upstream velocities and the downstream velocities, densities, temperatures, etc. So we'll study what is basic equation of normal shock. Now in a normal shock what happens is we have a duct supposingly, and in one side of the duct we have a velocity which is greater than Mach number, and here we have a velocity which is less than Mach number, during which there will be a creation of a shock. This shock wave is called as a normal shock. Now over here we have to apply continuity equation, considering the for an ideal fluid the area of cross section A1 as well as A2 is same. The other properties we'll take into consideration is pressure, temperature and density. Here also this is pressure P2, temperature T2 and density ρ2. So now for an ideal fluid the area is same, so we can apply mass conservation or continuity equation. Now in continuity equation we know that over here ρ1 A1 V1 is equals to ρ2 A2 V2. Now over here we can cancel A1 and A2 since both of them are same for an ideal fluid. So we get over here ρ1 into V1 is equals to ρ2 into V2. So we have got this equation over here. Now we know that the velocity can be represented in velocity of sound or in Mach number. So now we can write this velocity is equals to V by C is equals to M. So V1 by C1 is equals to M1 and V2 by C2 is equals to M2. So we can write over here this part, that is V1 is equals to M1 into C1 and V2 is equals to M2 into C2. Now by definition of velocity of sound, that is equals to square root of gamma RT, we have studied in the previous sections. So we can write this is equals to M1 into square root of gamma RT1, and this is M2 into square root of gamma RT2. So this is value of V1, V2 as well as V1 in terms of Mach number M1 and M2. Similarly, we know that the density rho is equals to P upon R into T. This is due to the ideal gas equation. So we can write ρ1 is equals to P1 R into T1 as well as ρ2 is equals to P2 R into T2. Let us substitute this in this equation, that is ρ1 V1 is equals to ρ2 V2. So ρ has a value of P1 R T1, V has a value of M1 into square root of gamma RT1 is equals to P2 upon R2 square root of gamma R into T2. So on evaluation of this we can cut here gamma as well as gamma. Similarly over here we can cancel this r's also, so there is no necessary of r. These two r's and these two r's will go away, and we will be left with over here your Mach number also we have to include. We will be left with over here P1 M1 into square root of T1 is equals to P2 M2 upon square root of T2. So this is the basic equation for a normal shock. The various parameters such as pressure, Mach number, temperature are linked to each other. So now let us see what is the change in the properties. Let us see what is change in fluid properties during normal shock. The first property change we'll see, that will be the change in pressure. So for change in pressure, what we'll see, we'll consider a duct. In this duct, the initial pressure is P1, the final pressure is P2, and the area of cross section is A. So over here we'll apply conservation of momentum. So we know that P1 minus P2 or P2 minus P1, any pressure we can take over here. So P1 minus P2 into area, or rather P1 should be greater than P2 for this entire fluid to go from one place to another place. Pardon my mistake over here. So from section 1 to section 2. So conservation of momentum. So the force over here is due to the pressure P1 minus P2 into area is equals to rho into area into velocity into its change in velocity over that entire course. So this is conservation of momentum. Since the area remains constant, we can cancel this part. So on further evaluation, we'll get this part as P1 minus P2 is equals to rho into V2 square minus V1 square. Now we can represent this entire part in terms of Mach number, but before that we'll take all the upstream values on the other side and the downstream value on one side. So this can be written as P1 plus a rho into V1 square is equals to P2 plus a rho into V2 square. Now we can represent this velocity of the fluid in terms of Mach number. So we know that V1 will be equals to, so we have got this equation. We can substitute the value of V1, which is equals to M1 into C1, and V2 is equals to M2 into C2. Along with this, here this will be density rho 1, here this will be density rho 2, depending upon the initial and the final density at the inlet condition and the outlet condition. Along with this, this density can be written as rho is equals to P1 upon R into T1, which we have seen in the previous sections, and rho 2 is equals to P2 upon R into T2. With this also we can write V1 square is equals to M1 square into C1 square, and V2 square is equals to M2 square into C2 square, where C is equals to square root of gamma R into T1 C1, and C2 will be equals to square root of gamma R into T2. So this can be written as V1 square is equals to M1 square gamma R into T1, and V2 square is equals to C2 into gamma R into T2. So all these variables will substitute in this equation, that is variable of V1, V2, rho 1 as well as rho 2. So when we substitute the variables, so what we get over here, this will be P1 plus P1 upon R into T1 into M1 square into gamma into R into T1 is equals to P2 plus P2 upon R into T2 into M2 square into gamma R into T2. So over here the values of gamma R into T2, gamma R into T2, gamma R into T1, gamma R without the gamma, these all values will go away and we will be left with over here P1 common into 1 plus gamma into M1 square is equals to P2 common 1 plus gamma into M2 square. So this can be written as P2 by P1, P2 by P1 is equals to 1 plus gamma into M1 square upon 1 plus gamma into M2 square. So this is what is variation of pressure when it goes from a supersonic flow to a subsonic flow during a normal shock. So we have seen the variation in pressure. Now we'll see what is variation in temperature. So for variation in temperature, we'll use what is energy equation. So let us apply what is energy equation. Now we know that energy equation is steady flow energy equation from applied thermodynamics. So here we'll not consider all the terms, we'll only consider a few terms which will be necessary over here. That is the enthalpy which will be changing, and V1 square by 2 is equals to H2 plus V2 square by 2. So this is what is steady flow energy equation. Now in this part over here we know that H1 will be equals to, or rather enthalpy is equals to Cp into temperature, hence H1 is equals to Cp into T1 and H2 is equals to Cp into T2. Along with this, we know that V is equals to M into gamma R into T. So V1 will be equals to, or V1 square will be equals to M1 square into gamma R into T1. Similarly, V2 square is equals to M2 square into gamma R into T2. So this value we have seen. Now let us substitute these two values in steady flow energy equation and let us calculate what is ratio of the temperatures T1 and T2, that is the upstream temperature and the downstream temperature. So over here we will substitute, this is Cp into T1 plus M1 square into gamma R into T1 upon 2 is equals to Cp into T2 plus M2 square into gamma R into T2 upon 2. So these values we have substituted. Now we need ratio of T1 by T2. So let us take over here, we can eliminate Cp altogether over here by taking common. Cp into T1 into 1 plus M1 square into gamma R upon 2 times Cp into T1 is equals to Cp into T2 into 1 plus M2 square gamma R upon, here T1 won't be in consideration, upon 2 Cp. So this will be the entire part which will be having. Over here value of Cp will go away and we'll be left with this equation. In this equation, let me write this all over again. So we have over here T1 into 1 plus M1 square gamma R upon 2 times Cp is equals to T2 into 1 plus M2 square gamma R upon 2 times Cp. Now, एक मिनट 2 times Cp. Now over here in both the equation we have these two constants R upon Cp. We can eliminate this. How we can eliminate this? We know that Cp minus Cv is equals to R and Cp by Cv is equals to gamma. So we can just divide this by Cp. So we'll get this as 1 minus Cv by Cp is equals to R upon Cp. So this is 1 minus, we know that Cp by Cv is equals to gamma. So inverse of that will be 1 upon gamma is equals to R upon Cp. So we cross multiply. Gamma upon gamma minus 1 upon gamma is equals to R upon Cp. Now, so in this equation, when we'll substitute the value of gamma will go away and we'll be left with m1 square into gamma minus 1 upon 2. So we can write this equation T1 into 1 plus m1 square into gamma upon 2. Instead of R upon Cp we can write over here this is gamma minus 1 upon gamma is equals to T2 into 1 plus m2 square into gamma upon 2 gamma minus 1 upon gamma. So these values of gamma will go away and we are left with these two equations which is similar to the stagnation temperatures. So we can write this part as equals to T1 upon T2 which will be equals to 1 plus m2 square upon gamma minus 1 upon 2 the whole upon 1 plus m1 square into gamma minus 1 upon 2. So this is equation of temperature in terms of upstream and downstream flow. So now we are going to establish relationship between Mach number. For establishing relationship between Mach number, we need to have basic equation of normal shock. So from our previous sections, we have studied what is basic equation of normal shocks. So from our previous sections, we know that the equation of normal shocks which we have studied, that is equals to P1 M1 upon root over T1 is equals to P2 T2 root over T2. So let us apply that over here. So we get over here that is P1 M1 upon root of T1 is equals to P2 M2 upon square root of T2. Now over here we have what is relationship between P2 by P1 or P1 by P2. So we have seen from the previous sections P2 by P1 is 1 plus gamma M1 square upon 1 plus gamma M2 square. So now we can write this. Let us write down over here P2 by P1 is equals to 1 plus gamma into M1 square upon 1 plus gamma into M2 square. Along with this we have T2 by T1. So if we have to substitute M1 in terms of M2, so we'll get this as M2 is equals to M1 is equals to M2 times P2 by P1 into square root of T1 by T2. So M1 will be equals to M1 square is equals to M2 square into P2 by P1 the whole square into T1 by T2. So these values we have seen. So let us substitute back in the equation. So what do we get over here? this is equals to m1 square. m1 square is equals to m2 square into p2. We have to substitute the value of p2, that is 1 plus gamma into m1 square upon 1 plus gamma into m2 the whole square into t1 by t2, that is 1 plus m2 square, 1 plus m2 square into gamma minus 1 upon 2 the whole upon 1 plus gamma into m2 square gamma minus 1 upon 2. Gamma won't be there. So on simplifying this entire term, we'll get, on simplification, of this entire part, we'll get this entire part as equals to m2 square is equals to 2 plus gamma minus 1 into m1 square the whole upon 2 into gamma into m1 square minus gamma minus 1. So this entire part we will derive on simplification of this entire part. So we have seen what is relation of m2 with respect to m1. Now the last part we can substitute, that is density in terms of one in terms of other. So on simplification we have got this Mach number 2, this is downstream Mach number in terms of Mach number 1. Note that over here we have m1, that is Mach number 1. So now this is Mach number 1 in terms of Mach number 2, and before this we have studied that P2 by P1 is equals to 1 plus gamma into m1 square upon 1 plus gamma into m2 square, that is Mach number 2 square. This is one of the thing. The second thing is T2 by T1, which we have studied initially, is equals to 1 plus m1 square into gamma minus 1 upon 2 the whole upon 1 plus m2 square into gamma minus 1 the whole upon 2. So now over here we have Mach number m1 as well as m2, so we can substitute the value of m2 in this equation, m2 square and m2 square in this equation. So on simplification of this we'll get Mach number in terms of only we'll get a property, that is P2 by P1 or T2 by T1 or T1 by T2 in terms of a single Mach number m1 over here. So now on simplification of this part we'll get P2 by P1 P2 by P1 in just terms of m1, that will be given as 2 gamma m1 square minus gamma minus 1 the whole upon gamma plus 1. Similarly T2 by T1 will be given as gamma minus 1 into m1 square plus 2 into 2 into gamma m1 square minus gamma minus 1 the whole upon gamma plus 1 the whole square into m1 square. So these two values we have got in terms of only Mach number m1. We can use the previous section if we know the Mach number m2. Along with this we know that rho 2 by rho 1 is equals to P2 by P1 into T1 by T2. So we have seen this initially, the R will go away. On solving rho 2 by rho 1, on solving this rho 2 by rho 1 will get this equals to gamma plus 1 upon m1 square upon gamma minus 1 m1 square plus 2. So we have to just substitute these two values, we have to divide these two values, we'll get rho 2 by rho 1 over here. Note that this will be multiplied by this won't be multiplied by m1 square. So these are the values over here. So we have got rho 2 by rho 1 as well as p2 by p1, t2 by t1. These are the change in the properties. Along with this, we have to study what is the shock strength. Now shock strength is defined as P2 minus P1 upon P1. So that is the change in the pressure upon its initial pressure. So over here we know that this can be written as P2 by P1 minus 1, or this can be written as equals to 2 gamma m1 square minus gamma minus 1 upon gamma plus 1 the whole minus 1. We know that P2 by P1 in terms of Mach number m1 is equals to this entire value. So we'll substitute this 2 into gamma into m1 square minus gamma minus 1 the whole minus gamma plus 1 the entire thing upon gamma plus 1. So if we open the bracket over here, so this will be equals to 2 into gamma into m1 square minus gamma plus 1 minus gamma minus 1. So over here this gamma value, this plus 1 minus 1 will go away, gamma will be remaining, so we'll get this upon gamma plus 1. So the numerator will give us, including the value of gamma, so that will give us P2 by P1 minus 1 is equals to 2 into gamma m1 square minus 2 gamma upon gamma plus 1. So if we take 2 gamma common over here, so this is m1 square minus 1 upon gamma plus 1. So this is what is the shock strength. So we have calculated, we have seen, we have derived also, we have studied what is the shock strength. We have studied the relation between m1 and m2, that is the Mach number 1 as well as Mach number 2, and we have studied what is T2 by T1, the relationship between upstream temperature and downstream temperature. Along with that, we have seen what is relationship between upstream pressure, density and temperature. So I hope you have understood how we have seen what is the change in the properties along normal shocks and basic equation of normal shocks. Thank you.